If you ever created an amortization schedule in Excel, you might be tempted to structure it this way, where you've got the period, the starting amount, the payment, the interest and principal portions, and your ending balance. And then you follow that through all the way to the end. Now, that can be a bit of a tedious process, but it gets the job done. You can get your interest and principal amount, you can look at individual periods or for ranges, and tally all that up that you need. But you don't have to create a schedule every time. I'm going to show you how you can create your own amortization calculator to pull in these individual amounts for a specific period or even a range of periods. Like, let's say you want to get all your interest payments for a certain year or the amount of principal you paid for a specific year. I'm going to show you how you can do that using some functions in Excel. So for starters, I'm going to build this out as a sort of template. So I'm going to start with some inputs that you're going to need to enter every time you're entering a new loan. So one of them is going to be the start of the loan. So this can be your loan date effectively. Then we've got the loan amount, the interest rate, the number of periods in your schedule, and then the period to calculate the amounts for. And so I'm just going to make these fields, the idea being that you enter them in. So for this example, I'm going to use January 2024 as my start date of the loan. So it's going to default to January 1, 2024. The loan amount I'm going to say is $500,000. The interest rate set to 5%. 120 periods, so that's saying 10 years. So 10 years times 12 months is 120 periods. And then what I'm also going to do is specify the period that I want to calculate my amounts for. In this case, it's going to be December 2025. So this will say December 1, 2025, January 1, 2024. So those are going to be the inputs. So I'm going to highlight them in yellow just to make it clear. These are the values that I want a user to enter in. Next, I'm going to calculate the formulas that I need. So one is going to be for the payment amount. So whether you're doing a full schedule or you just want to create a calculator, you're going to need to know what that payment amount is. So my assumption is this is a monthly amortization schedule with monthly compounding. So for the payment function, we're going to take the interest rate divided by 12, specify a number of periods, which is 120, and then the present value is going to be negative 500,000 because we have to pay that off. So we're have an amount owing, so that's a negative. And then our future value is 0 with the loan being paid off once the term is done. So that tells us our monthly payment amount is $5,303.28. Next, we need to know the period number. And this is a really important one that you might normally not need to calculate, especially if you're just doing an entire schedule. So what we wanted to do is calculate what period we're calculating for, right? We know December 2025, but we need to know the period number. So if January 2024 is the first month, December 2025 is going to be the 24th month, because after the end of December 2025, we'll have completed 2 full years, so 24 monthly payments. So to get this period number, we're going to use a function that may not be that well known or obvious in Excel, and that is the date diff function. And I say that because you type it in, it doesn't even seem like it's a function. There's no it doesn't auto complete here. If I open up the parentheses, it doesn't even tell me what arguments to put in here. You can go through the help and then you'll find some more information. But basically what we need to do is specify the start date as the first argument, the ending date as the next argument, and then the interval, in this case, which is going to be M for months. So I'm going to calculate the number of months between that start date and the end date. It gives me a value of 23. And that's because there hasn't been a full 24 months that have elapsed between those dates. So I need to add a +1 to this, just to make sure that I'm actually calculating for that 24th period. So the date diff function tells me how many months have elapsed from that start date to the end date. But because it hasn't been a full 24 months, I have to add a 1 just to make sure that I'm calculating for that December 2025 period. So next, I'm going to calculate my monthly interest. And to do this, I'm going to use the IPMT function. And for this, we're going to use, for a lot of these functions, it's going to be the same types of information over and over again. So like the rate, we got 5% divided by 12. For the period number, now this is not the number of periods. This is just the period that we're calculating for. So this is why we needed to calculate this period number first. And then the number of periods, we still need to reference that 120 because so it knows that what the payment amount would be and all those other calculations. The present value is going to be still that negative 500,000. And it tells us that the monthly interest is $1,760.19. Next up, let's do the monthly principal. And so this will be the principal portion of the payment. Now this is so similar in terms of inputs that I'm just going to copy and paste that formula entirely over here. The only thing I'm going to change, so right now you can see that it's exactly the same. The only thing I'm going to change, instead of IPMT, it's going to be PPMT for principal. And so that tells me $3,543.08. Now if I sum these totals up, if I just add them together, they match up to my payment, right? So I know it matches up and everything's accounted for, nothing's missing. The last piece I'm going to enter in is my ending balance. And for this, all we need to do is use the future value function. In this case, again, we're going to the rate again, 5% divided by 12, number of periods is 120. This time, we're going to reference our payment amount, our negative present value. Got that? And oh, we made a mistake there. So again, number of periods, we're not selecting that 120. As tempting as it might be, we actually need to reference that period number because remember, we want the period as of the end of period 24, not at the period 120, because obviously it'll be 0 at that point. So as you can see, a really easy mistake to make. So just pay attention that if you're looking at the future value as of the end of a specific time frame, you want to specify that specific period, not the whole entire loan term. And so now we've got a balance of $418,902.79. So now let's quickly prove this out with an amortization schedule. Right? Let's do this the manual way just to prove it out. So let's start with period 1. Right? Let's do the starting balance, the payment, the interest, principal, and our ending balance. And so if we start at 500,000, we've got our payment amount, 5303, that's going to stay fixed. Our interest amount is going to be our balance times that 5% divided by 12. And so we're going to lock down that 5% in our calculation. Our principal, payment, minus the interest. And let's do our ending balance is our start date, our start amount less the principal. And then set up our formulas and we should be good to go. So if I copy everything properly, it looks like it'll be good. So let's get down to period 24 here. And let's go a little bit further. And let's see that we match up. So obviously the payment amount intact. We've got 1760 matches up our monthly principal 3543.08. We've got that, and our ending balance matches up. So as you can see, it does work. We've got that calculating properly. So the good thing about this is we can specify in our calculator exactly what period we want to solve for. And although it didn't take a long time to create this schedule, as you can imagine, if you've got a lot of schedules, a lot of calculations that you need to do, you may not want to create, 10 different schedules. If you got 10 different loans you need to do this for. If you need to do this in a quick snapshot, just creating a single column for a loan is going to make it a whole lot easier for you to be able to manage multiple loan balance, interest payments, all that sort of thing. Now let's move on to a more complicated example. This time I'm going to create a calculator where we're going to look at multiple periods. Okay, so I'm going to copy my inputs here and paste this down here. So we've got our start of loan, we've got our loan amount, our interest rate, number of periods. This time I'm going to say our starting period for our calculations. And then I'm going to have an ending period for our calculations as well. And so just to make this a little bit different, let's just change this to a start date of June 2023. Leave the 500,000, leave these as inputs. And let's say January 2025 through to December 2025. So in this case, we want to grab a full year of 2025 data. So we want January through to the end of December. So we want all 12 months. So we say our loan started in June 2023. So it's not a neat little cutoff at the start of the year. And we want to look at just 2025. So this is going to be a little bit trickier. We're going to use some different functions, but as you can see, it's still going to be very doable to set this up. So for the payment formula, actually we can just copy the payment formula because the logic's essentially the same thing here. I'll just have to update these references here. So for the rate, I just want to specify we got that rate. For our number of periods, get that. And then our balance is there. So 5303.28. So exact same payment amount, not an issue there. Now we need to calculate the starting period number and the ending period number. And so this is where, again, we're going to need to use that date diff function again. So this time our start date is June 2023. And then our end date is going to be, well, our first end date is January 2025. And then, again, M. And then I'm going to add 1 to this. And so let's convert this into a number. Make sure we got the right format. And so that tells us that the starting period, January 2025, is the 20th period. And if you think about it, about the process, you know, with June 2023 being June the 1st, so effectively, let's say the end of May, right? So because June hasn't happened yet. So June through the end of the year, June is the 6th month. So that means you've got 7 full months before the end of the year. We've got June, July, August, September, October, November, December. And that would get us to the end of 2023. Another 12 months for all of 2024 would get us to 19 periods. And that 20th period would be January 2025. Okay, so I'll prove this out again later just to make sure that everything matches up. But that's our starting period. We could follow the same logic as well here for this other one. For this other period where, you know, instead of January 25, we use December 2025. And that's period 31. So we have our range. Period 20 to period 31 is what we're calculating for. Now let's calculate our total interest payments. And for this, we're going to use a different function similar to the iPayment, but it's a CUM iPayment, so cumulative iPayment function. And again, still going to be really similar. We're taking the interest rate divided by 12, the number of periods. So when it says end per, that's the total period for the loan amount. So that's going to be that 120. Our present value is going to be this 500,000. We need to specify our start date. And that's going to be our first period. And our end period is going to be our last one. And then if I close this out, and actually this one actually makes me specify the period type. So end of period, end of period by default. Obviously, if you've got a different loan setup was beginning of period, you can change that, but I'm sticking with the default in this example here. And so we've got a negative amount. Now I cannot put a negative amount for this loan amount, otherwise I get an error. So instead, what I'm going to do to avoid having a negative result is just add a dash at the front here. And so now my total interest payments during this stretch for the whole year of 2025 will be $20,851.88. Now, let's do the same this time for the total principal payments. And the good thing about this is, just like in the previous example, these formulas are largely going to be the same. So I can copy this exact logic over, and the main difference is instead of CUMI payment, it's going to be CUMPRINC, cumulative principal. And so here we've got $42,787.43. And so if this is covering a period of 12 months, we can actually check our work here by taking this payment amount, multiplying it by 12. So that would be the total of our monthly payments. And then let's take this, subtract the principal, subtract the interest, and we get to 0. So as you can see, again, everything's accounted for. Our totals line up. The last thing is we may just want to pull in the ending balance here. And here again, we're going to go back to the future value calculation where we're taking that rate divided by 12, the number of periods. This is going to be the period as of the end of December 2025. So it's period 31. The payment amount is our payment amount from here, and our negative present value start point. And so that tells us our balance at the end will be $393,684.37. Now let's try and prove this out again. So I'm going to copy the formulas that I set up over here, and let's do this again for this schedule. I'll have to move some of these amounts, some of these formulas around. Let's say start date, start amount 500,000. Our payment amount can stay the same. Our interest amount, we've locked that down, so I just have to adjust that. So we've got that interest rate, and I guess that could stay the same as well because it really doesn't matter. Principal, right, logic is matching up. Yes, so since our payments are the same, it doesn't really matter here. Ultimately, I'm looking at periods 20 through to 31. And let's just make sure we've got those captured here. So 20 to 31. So these are our ranges that we're looking for. So I'm going to do a summation just for those. So here we've got the interest amounts and the principal. So these are the key ones I'm going to be looking at. So I'm going to highlight those here. And so from 20 through to 31, we're going to do a summation here. Period 20. Our total 20,851.88 matches that. Let's do the same thing for the interest portion, or for the principal portion. And you can see from 20 through to 31, we've got 42,787.43. Obviously, there's a little bit of a rounding issue, but that's all that is. So it could just be that the payment amount here wasn't to the same percentage point, or whatever the case may be. But that's basically the only difference. But as you can see, the ending balance matches up as well, 393,684.37. So we've got the same amounts as to, whether we've done it manually or through the calculator. And the benefit of doing it this way, obviously, is, you can copy this logic over multiple times and reuse this calculator for multiple loans with a loan schedule. Even though it's not terribly complex to set up, as you can see, it doesn't take more than even a few minutes to set this up, but it does take up a bit of space, and you'd have to make sure all these things are linking to the right cells, to the right loans, and so it can get complicated if you're trying to do it at a large volume, if you're managing a lot of different loans, and you need your amounts to all add up and to consolidate all that stuff. So by using a calculator like this, using these functions such as date diff, cumulative payment, cumulative principal, you can calculate the range, the amounts for a specific range, or you can just specify the amounts for a specific period as well. If you're looking at just the payment amount, the interest payment for a certain period, or the principal payment for a certain period. So you can do that as well. So I'll leave a link where you can download this file if you want to follow along. and test it out yourself. If you like this video and learned a lot from it, please leave a like and be sure to subscribe. Thanks for watching.